Imagine diode is like an electrical valve that allow current to flow in one direction with far greater ease than in the other. A diode has two terminals, a plus terminal called anode, and a minus terminal called cathode. This is the schematic symbol of a diode. The arrow is pointing in the direction of the current, as opposed to the flow of electrons. I usually think of the vertical line at the pointy end of the arrow as it resembles a sideway minus sign. That is the cathode of the diode. Let's connect the diode in series with a lamp. When connected this way, the lamp light up indicates that there's a current flowing through the lamp. In this case, the diode is said to be forward biased. But if I reverse the diode, the lamp won't light up because the diode prevents the current from flowing. This is where the diode is said to be reverse biased. For a typical diode, a certain amount of forward voltage required before any current will flow. This minimum threshold of voltage is called forward voltage drop. For typical silicon diodes, this forward voltage drop is around 0.6 volt. Anyway, the ability of a diode to withstand reverse bias is limited. If the applied reverse bias voltage is large enough, the diode will break down. And when that happens, there's a good chance the diode is damaged. You can look in the diode's datasheet for the peak reverse voltage value. That is the maximum reverse bias voltage that the particular diode can withstand. The datasheet also indicates the maximum current ratings. Make sure your diode isn't exposed to more than these ratings, or you'll risk permanently damage the diode. There are lots of different kinds of diodes. Let's go through some of the most common ones. Signal diodes, also known as switching diodes or high-speed diodes. These type of diode are designed to be fast but can only handle small current flows. The most commonly used is the 1N4148 and 1N914. These two diodes are quite similar and can be used interchangeably. They have a forward voltage drop of 0.6 volt and peak reverse voltage of 100 volts. They can carry a maximum current of 200 milliamps. Some of signal diodes are made of germanium instead of silicon, and they have much smaller forward voltage drop than silicon diodes, and that can be as low as 0.15 volt. They come in handy for some radio applications, which often deal with very weak signal. Signal diodes such as the 1N4148 often find themselves used with inductors or relays to protect surrounding circuits from voltage spikes that can occur when the power to the inductor suddenly shuts off. Rectifier diodes. These is the type of diode you use when you want to convert alternating current into direct current. The most common ones are 1N4001 to 1N4007. They can handle higher current up to 1 amp. Their peak reverse voltage range from 50 to 1000 volts. In household mains AC supply, the voltage swings from positive to negative in cycle that repeat 50 to 60 times per second. If you place a rectifier diode in series with an AC voltage, you eliminate the negative side of the voltage cycle and so end up with just positive voltage. This AC to DC conversion is called a half-wave rectifier, because it passes along only half of the incoming AC waveform. There's a better type of rectifier circuit that uses 4 rectifier diodes. This is called a bridge rectifier. A bridge rectifier is more efficient than a half-wave rectifier, in that it allows both half of the AC wave to pass through. The negative half of the wave is inverted so it becomes positive. The Zener diode generally behaves very similarly to a signal or a rectifier diode, except that its breakdown voltage is lower. The Zener diode is intended to allow current to flow when the peak reverse voltage is reached or exceeded. The peak reverse voltage of a Zener diode is called Zener voltage. As you can see, the schematic of a Zener diode is a bit different from a normal diode. The unique behavior of the Zener diode makes it usable as a very simple voltage controller when placed in series with a resistor. This is a simplified basic circuit illustrating the ability of a Zener diode to compensate for variation in the power supply or load in a circuit, creating an approximately constant voltage at point A. A light-emitting diode, or LED, is a special type of diode that emits visible light when current passes through it. LED come in variety of colors.